Hello, welcome to Jedi Lesson 12. This is week 7B homework and problem number 1. An indium nucleus contains 49 protons and 66 neutrons. Which one is the following symbol describes this nucleus? So this one hopefully will be pretty simple to understand. But the first thing I want to do is we have our element here, which is indium. And then the standard nuclear isotope notation is going to be our mass number up here. And so mass number just means that you're adding the protons and the neutrons. So we can go ahead and do that in a little bit. And then the bottom number, I'll just represent Z, A, and then Z here is going to be the atomic number. And that is just protons. Okay, so now that we have our standard notation, then we can plug everything in. So we have our element. Our mass number is the protons, so we have 49 protons plus 66 neutrons. And then our atomic number is the number of protons, so we have 49 protons. And then to just simplify that into a solid notation, 49 plus 66 is going to equal 115. And then our 49 protons. So this should be the final symbol that describes this nucleus, and we can check that out. And okay, this is the second problem in the homework, and this states what is the radius r of zinc nucleus, 6430 nucleus. So first we can draw the image to help us visualize this. So this is our nucleus zoomed in, and then we have the radius here, which we're trying to find. So I'm going to put a question mark, and then this is representative of the 6430 Cn nucleus. And then we have a few electrons and protons that are just moving around here. So now that we have this, we know that A is going to equal 64, because remember in the previous problem we talked about how to draw the symbol, and A is the mass number. So our mass number is 64 here. And then we're going to use the equation R equals R0 times A 1/3. And some things to define here is that R is our radius. It's measured in in meters. And then R0 is the nuclear radius, and that's a constant, which is 1.2 times 10 to the negative 15 meters. So SI units are also meters. And then the last thing is the mass number. Remember, we got that by adding our protons and neutrons together. And this is dimensionless, so no SI units. So the first thing we want to do is, since we've already defined that A is 64, we can plug it into our new equation. And then R0 is given by the constant there, so we go ahead and plug that in. So 1.2 times 10 to the negative 15th meters, and then times RA, 64, to the 1/3 power. And so then we can go ahead and cube that. 3rd equals 4, because we know 4 times 4 times 4 is going to be 64. And so then we have our final radius is 1.2 times 10 to the negative 15th m times 4, which results in 4.8 times 10 to the negative 15th meters. And that's our our final radius. So then we can write it onto our image here. R2 is going to equal 4.8 times 10 to the negative 15th meters. And let's go ahead and check that. And that's correct.